Yesterday we learned how to calculate molar mass, and today we're going to learn how to use that to do some conversions. So we have three quantities that we know. We've got mass, moles, and number of things, which is usually molecules or atoms. And we can use those to convert between any, or we can convert between any of three of those using two conversion factors. The first one is that 1 mole of anything equals 6.02 times 10 to the 23rd of that thing. And the second one is that 1 mole of a substance equals the molar mass for that substance. The common questions look like this, where you've got how many atoms of sulfur are contained in 2.1 moles of sulfur. For a conversion problem, you always write down what you're given first, which is 2.1 moles of sulfur. And then now inside Foldy, this is your best friend. From now on, you will always use this, which is called a mole wheel. And you just, the arrows tell you where to go, and then the parentheses tell you what conversion factor to use. So if I'm starting at moles, and I want to know how many atoms are there, if I'm starting at moles, I want to get to atoms, I just follow the direction of the arrow. That's my conversion factor right there. So I write 2 moles, 2.1 moles of sulfur times 6.02 times 10 to the 23rd atoms in 1 mole. Notice moles cancel out, and the math that you do is 2.1 times 6.02 times 10 to the 23rd. I would use your calculator like this and do 2.1 times 6.02 times 10 to the 23rd, like so, and you get 1.26 times 10 to the 24th. 0.26 times 10 to the 24th, and that would be atoms of sulfur for your label. You can do the same thing here with sulfur dioxide. How many grams of sulfur dioxide are contained in 3.1 moles of sulfur dioxide? Again, always start with what you're given, which is 3.1 moles of sulfur dioxide. That's SO2. And I'm starting at moles, and I want to get to grams. Starting at moles, I want to go to grams. So here's my conversion factor. That MM, that means molar mass. You have to calculate that for sulfur dioxide. So off to the margin here, I'd write for sulfur, it's 32 grams. For oxygen, it's 2 times 16 for a grand total of 64. So you'd write the molar mass here is 64 grams and 1 mole on bottom. Again, you're just following what it says already here on the mole wheel. And then you'd have 3.1 times 64 this time. So do that on your calculator. 3.1 times 64. And the answer is 198.4. In terms of units, you would write at least grams, but probably you also would write sulfur as well. Last one is how many molecules are contained in 14 grams of sulfur hexafluoride. 14 grams, sulfur hexafluoride is SF6. You are at grams, and now you want to go all the way up to molecules. This happens to be a two-step problem. First you go from mass to moles, and then you go from moles to molecules. So the first one is 1 mole over the molar mass. 1 mole over the molar mass of SF6. You've got to add it up. Sulfur is 32, and there are 6 fluorines. That's 19 times 6. So 146. And then keep that there, because you're going to tack on the last one too, which is going from moles up to molecules, which is 6.02 times 10 to the 23rd over 1 mole. And now moles cancels out, and grams cancels out, and you're left with molecules. That's what this should be. For the math here, take 14 times 6.02 times 10 to the 23rd divided by 146. Just multiply by everything on top and divide by everything on bottom, and you get 5.77 times 10 to the 22nd. 5.77 times 10 to the 22nd. And then this would be molecules of SF6. So there is 3 common conversion problems. You've got moles to atoms, you've got moles to grams, and you've got grams to molecules. And you can reverse all of those, but using the mole wheel and becoming familiar with how it works is going to be a really common theme for the rest of this year. So make sure you're comfortable with using this. We're only working on these 2 sides right now. We're not going to be doing this side with the gases yet. Okay? But that is what we did today.